All right, here's your final 11.2 video. There have been a lot. Today we're going to tackle the topics of rationalizing denominators, which sounds totally made up, but it's a real thing, and just adding radicals together. So, essential question, there are two this video. We're going to cover two kind of mini topics. First of all, if there's a square root in the denominator, how do I get it out? Second of all, how do I add square roots? So, rationalizing the denominator. This is what we'll talk about first. There are memes about it, so this is a real thing. Proved it, told you so. So here's the example. Okay, we dealt with fractions with square roots before, and we said that the square roots kind of distribute. Here, there's absolutely no way I can simplify, right? I have a 5 on top. This will not simplify with anything that's under the square root because the square root and the things outside, they need to be kept separate. But there's an issue. Mathematicians, when they see the square root in the denominator, they hate it. It makes them do this. Grrr. They don't like seeing the square root in the denominator. And so I need to figure out a way to get the square root out of the denominator. And it's called rationalizing the denominator, just like in the title of the video. I'm going to show you a trick. And I'm just watch the trick and you'll see. I'm allowed to multiply this fraction by something, right? Like if I made 2 root 7 on the bottom, I could also multiply the top by 2 to get 10, right? This is legal because I'm doing the same thing on the top and the bottom. Likewise, if I had like 8 over 6, couldn't I reduce this to 4 over 3? I can divide by the same thing on the top and the bottom. So you're used to doing this with fractions. So what I need to figure out how to do is I need to figure out what can I multiply this fraction by that's clever that will get the square root away. Because if I do the same thing on the top and the bottom, it's legal because that's how fractions work. So I'm going to multiply by the square root of 7 over the square root of 7, and we'll see what happens. First of all, is this legal? Well, yeah, this is just 1, right? If I have the same thing on the top and the bottom, they cancel to 1. So this is a legal thing to do. I really can multiply because I'm just multiplying by 1. On the top, nothing happens. This 5 does not combine with this square root because when you're multiplying, you only multiply things that are under the square roots together. But on the bottom, notice what happens. I'll kind of show this to the side. This is the square root of 49, right? Because I have 2 things under the square root, and yeah, so 7 times 7 is 49. But what's the square root of 49? Oh, it's 7. Wow, so I got rid of the square root. So this kind of seems like nonsense because this answer actually looks more complicated than the original problem. But I rationalized the denominator. So mission accomplished. I'll show you another example with this just so that you can get a good idea of what's going on. Okay, here. I have a square root on the bottom of my fraction. That's not allowed. So what I'm going to do is I'm going to multiply by the square root of 3b. Because notice what happens. Square root of 3b times square root of 3b is the square root of 9b squared, right? 3 times 3 is 9, b times b is b squared. But the square root of 9b is just 3b. So that's really cool. When I multiply by the same thing here and here, the square root ends up canceling, and that should make a whole lot of sense because you just invented a pair, right? But of course, if I do the same thing if I do something on the bottom, I need to do the same thing on the top. Here it is. And in this case, I do have 2 things under the square root, so they can combine. 2 times 3 is 6, so 6b. Notice that I'm not now able to cancel the 6 and the 3. Like I'm not able to reduce that because what's on the bottom is now not under the square root. Okay, so much for rationalizing the denominator. Now we also need to learn how to add and subtract radicals. And it's going to be the same way that I added and subtracted polynomials. So for example, if I had 2x squared plus 3x minus x squared, isn't it true that I need to combine the like terms? Right? We're combining like terms. So let's take a look here. I'm not able to do this. I'm not able to say, oh, this is the square root of 23. Yay! Just like I'm not able to say, hey, you guys, x squared times x squared is x to the 4th. No, it doesn't work like that. I'm just combining like terms. What are my like terms here? Well, this guy has a square root of 10, and this guy has a square root of 10. So I'm going to combine these 2 like terms. Negative 5 root 10, because 4 minus 9 is negative 5. This square root of 13 doesn't have a like term, so it is sad and lonely all by itself at the end. And that's it. I can't combine these anymore because these two are not like terms because they don't have the same square root. Okay, so all you're doing is you're combining like terms. We have totally done this before with polynomials, and it's the exact same thing. But of course, you know, just a reminder, yesterday, you know that if you're multiplying two things together, you multiply what's under the square root and multiply what's outside the square root, which in this case is just 4. And you would need to see if this can simplify. I happen to know it doesn't. But the point is, if we're adding, combine like terms. If we're multiplying, that's where I can actually take this and multiply it times this. Just like, even though I can't add x squared plus x, because they're not like terms, I can go x squared times x to get x cubed. Okay, so let's do another example. So I'm looking for like terms here, because I'm adding, but these don't have the same square root, right? These square roots don't match. But let's see if this simplifies. I happen to know that 48 is 16 times 3, and that's going to be 4 root 3. And you could do this using the tree method, but I just didn't feel like using the tree method right here. So really, after I simplify the square root of 48, I have 5 root 3 plus 4 root 3. And that's very convenient because now I do have like terms. I had to simplify first, but now I do have like terms. So it's going to be 9 root 3. Add the coefficients, leave the square root the same. 9 root 3, I combined like terms, which is something you guys totally know how to do. Now let's just compare that over here. I knew that this was 16 times 3. And remember, it's really helpful when I'm multiplying, because I am going to eventually be multiplying these together. If I break this guy down a little first, now I can do 5 times 16 times 3 times 3. This 3 and this 3 and then this 16. So I broke it down first because now I can see, oh, here's a pair and here's like a perfect square. So it'll be 5 times square root of 16 is 4 times pair of 3's, and 5 times 4 times 3 happens to be 60. Okay, so remember, when you're adding, combine like terms. When you're multiplying, that's where you can multiply what's under the radical. So I'm going to do just one more crazy problem with you. Take a look at this. This is really nuts. Inside parentheses, I'm adding, no like terms. Inside these parentheses, I'm adding, no like terms. But then I'm trying to multiply the parentheses together. What does this remind you of? Hopefully you're thinking FOIL, or since I kind of messed up my F, EOIL. So let's do the FOIL here, but it's tricky FOIL because it involves square roots. Let's see how quick we can do with it. Square root 7 times square root 7. Sort of seems like something I would do when I rationalize the denominator. Root 7 times root 7 is root 49, which is 7. Okay, so my first is 7. Next, root 7 times negative 3 root 2. Remember, things under the square root, since I'm multiplying here, remember I'm multiplying with FOIL, things under the square root multiply, things outside the square root multiplies. So negative 3, it has nothing to multiply with outside the square root, there's just a 1 in front here. But I can multiply 7 and 2 to get root 14. Now let's do inners. Well, there's nothing outside, it's just straight up root 14. And then finally here, let's do this one over to the side. Root 2 times negative 3 root 2. Wouldn't that be negative 3 times the square root of 4, which would be negative 3 times 2, which would be negative 6. Woo! Okay, and now that I've FOILed, I have a problem that looks much like this. And remember, I'm looking for like terms. So these are like terms. So I have negative 2 root 14. Remember, negative 3 plus 1 to get the negative 2. Radical stays the same. I also have 7 minus 6. Okay, that's it. 1 minus 2 root 14. And notice these two are not like terms. They do not combine. Wow, that was a crazy example, but it's nothing we haven't done. It's just all mixed up and packaged differently. So summary, if you had a radical in the denominator like examples 1 and 2, rationalize the denominator first by multiplying by the square root of what's in the denominator. And when adding radicals or radicals. Be sure to combine like terms. All right, thanks for watching.